State reduction. Actually, previously that race or cycles, state free assignment, that is we already discussed in previous videos. So the race, it's unequal delay happened in the circuit. So because of that, the circuit getting are harmless. So if it is harmless, that is a non-critical race. If it is harm, that is a critical race. So for avoiding the race, we just add another state. Then it's a race-free assignment. So that is we discussed in previous videos. And here, reduction of state and flow tables. So the procedure for reducing the number of internal state, the asynchronous sequential circuit, so that resembles the procedure that used to in synchronous circuits. So it's an implication table. So the implication table we have to follow for reducing the state. So the state reduction procedure for a completely specified state table is based on the algorithm. So there are two states in the state table can be combined into one if they can shown in the equivalent. Okay, so consider the following state table. So this is a present state A, B, C, D. So next state, so x0 and x1, and the output x0, x1. So they given. Um, so A, B, it's implies CD. So they, that consider the following state table. It's a fourth state. It's a that a 0 to 7, 8 state is there. So totally. So how if it is four state is there, then what's the state table, and if it is eight is there, what's the table they given? So it's an implication table. So implication table they drawn that B C D E F G. So the states are written here, and here also the states written here. Um, so D and um, so D and E. So the states they what they per B what the state they get it. So that is they written here. So D and E, and for F C and D, and C and E and A and B for C and D and A and D. So that is they written here. So A, B, C, D is a table. So they have to reduce using the cross mark. So if you want, you have to use that is a tick mark they given. So it's an implication table. So the step by the procedure the following the square is actually what are the procedures following the implication table. So you have to place a cross in any square corresponding to the pair of the state whose outputs are not equal for every input. So you have to cross any square corresponding to the pair of the states whose outputs are not equal for every inputs. So enter the remaining squares the pair of the state that are implied by pair of the state representing the squares. We do that by starting from the top square in the left column and going down in then proceeding with the next column to the right. So make successive passes through the table to determine whether it is additional square should be made with a x. So that the x is here, a square in the table is crossed out if it contains at least one implied pair that is not equivalent. And finally, all the square that have no crosses are recorded with the check marks. So these are the steps you have to follow for complete the implication table. And here they reduce the table. They reduce the state table. Previously they having more states, up to 8 states are there. Then they reduced the ACD. Only 4 states are available. So reduced the state table based on the implication table. And this is a four flow table. Flow table means it's alphabetic letter only present in flow table. If it is transition table, they put it is instead of alphabetic letter, they put the value 0001 like that. Okay. So this is compactable pair and maximal compactable. Uh, okay. So remaining thing we will see next. Thank you.